In this video, we'll go over sign limits, but first of all, let's go over properties that are important to know to solve these problems. So these are some basic rules I would suggest memorizing. You'll use them a lot when dealing with limits, and they can be quite tricky to memorize, so what I'm always trying to do when I have to deal with some properties, I like to come up with methods that make it easier to work with them. For example, when I was learning logs, the thing that really helped me was the snail. Sounds weird, right? But let's say that we deal with solving log. What happens? You kind of go spiral way, right? So you can imagine that we basically have a snail this way. Somewhat like that. So I know it doesn't look like a snail, but still, probably something like that. I forgot how snails look like, so that's a way of memorizing it. So 10 raised to the second power is equal to x. So x is equal to 100. And the reason why it's important to have this method of memorizing things to come up with it every single time when you have difficult property is because it makes life so much easier. And if you will have to get back to this topic of limits at some point of your life, maybe you'll have the final exam, for example, or something like that, you'll have this method that is memorized in your head. Just like this snail. I'll remember it for the rest of my life because snails are nice and logs are not so nice. So the same thing can be done for the limits. It can be confusing that limit of infinity is reaching 0, but limit of 0 in this case is reaching 1. So what are some ways that we can memorize it? In my case, again, that's just a method. That's not how things work in this case, but it helps. Whenever we deal with any number that is raised to 0, it's always equal to 1, right? We can associate that with the following limit. It's not exactly what happens. We're not taking the exponent of sine of x over x, but it helps to memorize this thing. At least it helped me on my final exam when I was in high school. So again, that's not the way of solving that, but it helps. It might help at least. And when we have limit as x approaches infinity of sine of x over x, it's going to be 0. Also, it's true if we flip our trig fraction, it's going to equal to 1. And there is another thing. It's basically about substitution, pretty much, or squeeze theorem, in other words. We'll get to that in more details for, I believe, 8's problem, the last problem on the list for today. So let's get started with the problems. Again, we have the following property: as x approaches 0 of sine of x over x, it's going to be 1. But note that we have 2x. What are we doing in this case? Well, we want our denominator to be the same as whatever is inside of sine function. So we'll have to multiply the equation by 2 over 2 and rewrite our function. Now we can simplify that by looking at our basic limit rules. So we can say that it's 0, so sine of 2x over 2x, it's going to be 1. So the answer is going to be 2. Again, all we have to do is pretty much rewrite our limit just so it looks somewhat like the rule on the right. So we want to get rid of 4 in such a way that we'll have sine of 2x over 2x. And that is the answer. Again, we know that limit as x approaches 0 of sine of x over x is 1. So how can we rewrite this limit in such a way that we get to this form? Well, what we have to do is really get rid of this x. So it's basically the same as so the answer is 2. Again, how can we rewrite this limit in such a way that we'll get to the form that is similar to the rules we have on the right? So 0 is the answer for this problem. This one is a bit tricky, nevertheless you can solve it. Let's try splitting our limit into 2 parts. Now we want to rewrite it in such a way that this limit has 5x in denominator and this limit would have 4x in numerator. Now we can cancel sine of 5x over 5x and 4x over sine of 4x because it's going to be 1. And after that, we can say that we're left with 5x divided by x. So we can simplify that and say that it's the same as 5. And that is our answer. Limit as x approaches infinity of sine of x. What happens as we try to plug in numbers larger and larger? What happens to our function? The thing is that it's going to oscillate between -1 and 1. So what is the answer in this case? We'll just have limit that doesn't exist. So that is the answer. This is a moment where we have squeeze theorem that comes into play. How can we rewrite it in such a way that we'll actually have a fraction just so we can make our life easier and use one of the basic properties we have right here? Well, let's think about substitution. You'll get what I mean in just a second. So how can we rewrite x in such a way that we'll get our function to fraction? I can't say that x is 1 over x because it's basically x raised to -1, right? But what I can say for sure is that x is basically the same as 1 of 1 over x, right? Because x will go up top if I'll simplify that. we can use that piece of information to do some substitution. So we can say that there is theta. Theta is most commonly used. Theta that is equal to 1 over x, right? And just as we said right now before, x is the same as 1 over x. So right now, knowing that fact, let's substitute x to theta, and what is it going to reach? It's not going to be infinity anymore, right? Imagine that we're basically setting limit as x approaches infinity of 1 over x. What's that going to be? It's going to be 0, right? So now let's actually substitute theta into our function and rewrite that. Now we can finally simplify. Sorry, it's not equal sign. It's meant to be arrow. Now we can simplify that in such way that we have similar property and we can actually simplify our limit and solve it easily. What is limit as it approaches 0 of sine of x over x? That's just 1. So the answer would be 1. Again, we're going to use squeeze theorem just as we did in number 7. There is another way you can solve that, but that's a bit more advanced topic. It's L'Hopital's rule. I'll leave a link to that video in case if you're interested. Anyways, let's go with the easiest version. So we'll go with substitution and we'll use pi minus x as our value. So what happens as our x reaches pi in pi minus x? The value it's going to reach is 0, right? And let's substitute pi minus x as t, for example. It can be any variable that you'd like to use. It's not necessarily t. So now let's rewrite our limit. And we can look to the rate. And again, what is the limit as basically x approaches 0 of sine of x over x? That's going to be 1. So the answer is 1. That is it. Thank you for watching this video. If you liked it, please leave a comment below, subscribe to my channel. Good luck with your limits journey. Bye bye.